Alright, in this video class we're going to find the inverse, we're going to be doing inverse Laplace transforms for Heaviside functions. Okay, and this is the formula we need, so we're actually going to be going from here to there. And we're going to make an intermediate step, we're going to find the inverse transform for f, and then we're going to shift the t's to t minus a's. So that's how we're going to do that. Alright, so I took this problem out of the book, somewhere in the book, okay? So we have a Laplace transform is something that turned out to be 1 over s times s squared plus 4 minus 2e to the minus s over s times s squared plus 4 plus e to the minus 2s over s times s squared plus 4. Okay, so this is what we're going to find the inverse transform for. Before we can do that, we actually have to do partial fractions. And this one's not too bad, but in general you have to do a partial fraction for each Heaviside component. So that's something you're going to have to get used to. So when you do the transforms of your differential equations in your discontinuous right-hand sides, you want to group them. You want to group them in terms of their Heaviside piece. All right. So 1 over s times s squared plus 4. So if I do the partial fraction decomposition for this, it takes care of this term and the e to the minus 2s term, because those are the same thing. So this is going to be a over s plus bs plus c, bs plus c over s squared plus 4. Remember, that's an unfactorable quadratic. And then we also have negative 2 over s times s squared plus 4. You can actually even just do 1 and say that it's negative 2 times all of that if you want, because this one will work out pretty much similar. If you have more terms up here, so if you have an s term up here, you're going to need to do a completely different one. So that's going to be a over s plus bs plus c over s squared plus 4. Alright, so we have our equation that we get out of this is 1 equals a s squared plus 4 plus bs plus c s, and there's only one nice value, it's 0. But the rest of this isn't too terribly bad. So if s equals 0, all that's 0, so we get 4a equals 1, so a is 1/4. Okay, then we can group on s squared terms, and we get, there's no s squared terms on the left, so we would get that 0s squared is going to be as squared plus bs squared, so a plus b. So b is negative 1/4. And then you can group on s terms. There's no s terms over here, notice. But there is one here, so we get bs squared plus cs. There's no s term on the left, so 0 equals c. Okay? And I'm not going to go through, but if you do the same thing over here, you're going to get that when s equals 0, a is negative 1/2. And then if you group on s squared, you get a plus b equals 0 again. So b equals 1/2. And c is going to equal 0 when you group on s's. Alright, so let me rewrite this thing the way we need to see it. Okay, so this is going to take a little bit of room. So f of s is 1/4 s minus, or let me say plus, negative 1/4 s over s squared plus 4 plus e to the minus s negative 1/2 over s plus 1/2 s over s squared plus 4. Okay, and I can't fit that on the next line, so I'm just going to put it underneath, plus e to the minus 2s 1/4 s plus negative 1/4 s squared plus 4. Okay, so I'm going to do this in two pieces. So I'm going to take the inverse transforms of the inside parts, but I know that t is going to have to be shifted. So f of t, which is the inverse transform of f of s, equals, this part's pretty easy, okay? So s over s squared plus 4, that's a cosine term. Negative 1/4 is the coefficient. That's going to give me just 1/4. and my b here is 2, so cosine of 2t. Okay, and we know that when we take the inverse transform of e to the minus s, so I'm thinking going from here to here, so that e term turns into the u term. So this is going to be u of t minus 1, because that's the value of a. And then inside I have negative 1/2 plus 1/2 cos 2t. And t is shifted to t minus 1 there. Notice how I'm writing that. Okay, and then the last one, u of t minus 2, because a is 2, and that's times 1/4 minus 1/4 cosine 2t. And t is shifted to t minus 2 there. Okay, so last step here, I'm going to write f of t, and that's 1/4 minus 1/4 cos 2t plus u of t minus 1 times negative 1/2 plus 1/2 cosine of 2 t minus 1. Notice how I replace the t with t minus 1, and then u of t minus 2 times 1/4 minus 1/4 cosine of 2 t minus 2, and poof, we're done. Okay, so if we take the last 3 videos, you need all 3 of those to actually solve a differential equation with one of these.